to the next point.
Towards
We should ensure
us.
whatever we say is clear.
That means work is being done. We can see that it is in opposite direction.
Hello, my good students. You are welcome to Kaduna State Ministry of Education e-learning platform. My name is Mr. Philip Mamman, and today in chemistry, we'll be looking at the topic elements, symbols of elements, and formula of compounds. It's a very important rudiment in chemistry, so pay attention, get your pens and paper ready to get the important points. At the end of the lesson, you should be able to write the formula of any compound you come across in chemistry. I will start by looking at the definition of an element. An element is a chemical substance which cannot be split into simpler substances by any known chemical means. You are quite aware that we have over 110 elements that is already known. Examples of these elements like oxygen, sodium, iron, zinc, aluminium, carbon, and neon. These elements have been organized by scientists on the periodic table. Like I said earlier, there are over 110 elements that has been discovered, and you find out that every substance, every material on Earth contains one or more of these elements. As you can see them on the periodic table, you can see the periodic table. We have discussed the periodic table previously. These elements are arranged according to their properties and atomic numbers. Elements that have recurring properties belong to the same group, and they have the same valence electron. And like I said, across the period, they have the same number of shells. Today, we'll be dwelling on how you can identify an element by a symbol, and of course, how you can write the formula of a compound. But then, what is a symbol? Now, if we look at the symbol, we say symbol of an element is a type of chemical shorthand used to represent one atom or one molecule of that element. Like I said, one atom in case of atoms that can be multiple atomic, while one molecule in terms of an element that is monoatomic. Like you know, atomicity is the number of elements in one molecule. The symbols of elements have been developed in various ways. We're going to look at those ways, and we see those elements that fall into these categories. The first way is the fact that some elements have their symbol derived from the first alphabet in the name of that element, written in capital letter form. In other words, written in uppercase. You can see an example of those elements like hydrogen. The symbol is capital letter H. If you write anything other than capital letter H, you are not writing the symbol of hydrogen. Then the other one, boron, carbon, nitrogen, phosphorus, sulfur. As you can see, boron is capital letter B, carbon is capital letter C, nitrogen is capital letter N, phosphorus is capital letter P, and of course, sulfur is capital letter S. Now, having exhausted these alphabets, you have elements that have recurring alphabet as has been identified earlier. In that case, you take the second option, which is the first alphabet in the name of the element, written in capital letter form, and any other alphabet that is conspicuous, meaning very pronounced, in a small letter form. As can be seen here, you see example of helium, capital letter H, and the E is conspicuous. That's why it's written in small letter. So capital letter H, small letter E. Lithium, capital letter L, small letter I. Beryllium, capital letter B, small letter E. Neon, capital letter N, small letter E. Magnesium, capital letter M, small letter G. Aluminium, capital letter A, small letter L. And of course, calcium, capital letter C, small letter A. There are so many other examples as you come across in your pursuit in chemistry. Then we have the third options. When you have exhausted the two options I mentioned earlier, then you have to go through the Latin name of those elements. And when you have the Latin name, you take the options of the capital letter of the first alphabet in the name, on the Latin name of that element, and or any other alphabet in small letter form. Remember, the alphabet should be very, very conspicuous and pronounced. And these alphabets are universally taken. So you can see that in the case we have sodium, the Latin name of sodium is natrium. And that's why the symbol of sodium is capital letter N, small letter A. Then potassium, the The Latin name is Kalium, and that's why it's capital letter K. And iron is ferrum, and that's why it is capital letter F, small letter E. Now, we have copper, and copper is cuprum. You can see it there, and that's why the symbol is capital letter C, small letter U. Silver is argentum, and capital letter A, small letter G. We have others like mercury, hydrargyrum, and it is capital letter H, small letter G. Then we have tin, sternum, it's capital letter S, small letter N, and gold, aurum, capital letter A, small letter U. And finally, lead, capital letter P, small letter B, from the word plumbum. And that's why I'm sure that people that work on pipes in your houses, that's for water, but are called plumber, because the pipe is made up of lead. Move further as we'll be looking at how to write the formula or formulae of compounds. Now, to write the formula of compound, it's very important that we take into consideration very important things. And it's very, very sensitive because that's the genesis of how to write equations in chemistry. And of course, chemistry without equation is not chemistry. So take note of this, and I'm going to be mentioning. And I say the formula of a chemical compound is made up of symbol of all the component atoms written together, indicating as subscript against each atom the appropriate whole number of the atoms combining in the molecule. Now we can say, what is the formula of water? I know you all be shouting at home, H2O. But how did we get it? Some of you might not know. But if you follow me, you will get the logic, and it will be easy for you to write the formula of any other compound that you approach. You see, the first thing you have to take note is the valency of the constituent atoms or radicals. Now, I'll tell you what the radical is as we proceed. But of course, let's look at valency. Valency in chemistry is the combining power of an element. Valency is the combining power of an element. Now, valency is different from valence electron. Now, you may have had valence electron. Oftentimes, when you are marking exam papers, you see students interchanging valency and valence electron. Now, valency is the number of is the combining power of an element. But why valence electron is the number of electrons in the outermost shell. In some cases, they might be the same. In others, they are not the same. I'll give you an answer. The valency of sodium is 1. And the valence electrons in sodium is also 1. But the valency of chlorine is also 1. But the valence electron of sodium are 7. Because it has 7 electrons in the outermost shell. It can gain 1 electron to become stable. That's why we say the valency is 1. Now let's look at the concept of a radical. What is radical? We say radical are a group of atoms that behave as one unit, but they are a reactive species. Usually they carry a charge, either positive or negative. We'll be seeing them. Let me look at, you say, oxidation number and valency. Now, oxidation number is the charge that an ion carries, while valency can be represented as that oxidation number without the charge. For instance, the oxidation number of sodium is +1, but the valency of sodium is 1. The oxidation number of chlorine is -1, but the valency of chlorine is 1. So you can see, in other words, valency is oxidation number without a charge. So if you know the oxidation number, follow me, you can as well use it as your valency. Like I said, radicals. You can see radical, we have OH. They are a combination of 2 atoms, oxygen and hydrogen. We call it hydroxyl ion. Ammonium ion, nitrogen plus and hydrogen. You can see 4 atoms of hydrogen. You can see trioxocarbonate 4 and as the rest of them. So you see how we can arrive at the charges of each of these radicals. Now, these charges are not gotten from space. What we do is that we sum up the charges of the atoms combining. For instance, we say the oxidation number of oxygen is -2, and the oxidation number of hydrogen is +1. So if you put oxygen and hydrogen together to give you hydroxyl ion, it becomes -2 + 1. And that gives you the minus that is on top of OH. Of course. Then, of course, you see others. triazocarbonate 4. I'll just quickly look at that. You see, carbon is +4, and that's a +4, plus -2 for oxygen, and there are 3 oxygens there. That's why I'm multiplying by 3, and it gives you +4 minus 6 to give you -2, and that's why the CO3 is carrying 2 minus, and that's how you can get for so many other radicals as we come across. Now, properly, we'll be looking at how you can write these formulas of a compound. Step 1, identify the constituent element or radicals in the compound. I'll give you an example of water. You all know water is H2O. How many elements are in water? 2, hydrogen and oxygen. The next thing is to identify the valency or oxidation number of this constituent element. Remember I said hydrogen is +1 and oxygen is -2. Hydrogen is +1 and oxygen is -2. Because the oxidation number of hydrogen is +1, it means that the valency of hydrogen is 1. And the oxidation number of oxygen is -2. The valency of oxygen is 2. Remember I said valency is oxidation number without a charge. So the third step is, of course, that you have to interchange the valencies between the cations and the anions and write them as subscript. I hope you know what subscript is. You write them beneath. When I say interchange, it means that you take the oxidation or the valency of, for instance, water. You take the valency of hydrogen and give it to oxygen, and take the valency of oxygen and give it to hydrogen. That's what I mean by interchange. But I'd like you to note, of course, that cations are written on the left-hand side. When you're writing the formula of a compound, the cations must be on the left-hand side, and the anions should be on the right-hand side. Then they can also, these valencies can also cancel out when they are of the same factors. But note that the number attached to the radical should not be tampered with. I will show you when we proceed in the examples. Example number 1. Now, before I go to the example, I'll just give you a highlight of some of these anions or cations with their valency and oxidation number because of their group. Obviously, hydrogen ion, lithium ion, silver ion, sodium ion, potassium ion, and ammonium ion all has a valency of 1, as you can see. Then, of course, you see we have others like mercury ion, copper 1. Now, when you are talking about transition element, they have variable oxidation state. So usually the oxidation state is mentioned in their name. For instance, copper 1, meaning that copper has oxidation number of 1. Beryllium is +2. Then carbon 2, we have carbon 2 in case of carbon 2 oxide and carbon 4 in case of carbon 4 oxide. So when you say carbon 2, it means that the oxidation number of carbon is 2. Magnesium is +2. Calcium is +2. Because they don't have variable oxidation state, so we also only mention, they only have 1, so you cannot put it in their name. Then we have iron, iron 2, lead 2, all having valency of 2, 2. I'm sure you'll be able to remember these things as very, very important for you when you'll be writing the formula. Then we have mercury 2, zinc. Zinc is not a transition metal, so that's why we don't give it oxidation number. Aluminium 3, we have carbon 4, sulfur 4, and sulfur 2 ions. Now, these are their valencies as well as their oxidation numbers. Now, let's look at the anion. You have hydroxyl ion as the case of OH, hydrogen tetraoxosulfate 6 -1, hydrogen trioxosulfate 4 -1, hydrogen trioxocarbonate 4 -1. The oxidation state, the valencies are all 1. Then we have chloride, bromide, iodide, trioxonitrate 5, trioxochlorate 5, tetraoxomanganate 7, all having valency of 1, 1, 1. Then the other ones are hydride. Remember, hydrogen can be positive and negative. When hydrogen is on the negative side, it's called an hydride ion, -1. Oxide ion, tetraoxosulfate 4, tetraoxosulfate 6, trioxocarbonate 4, and heptaoxochromate 6. Of course, tetraoxosulfate 5. They have 1 valency, 2, 2, and of course 3. Tetraoxophosphate 5 has a valency of 3. It's good you know these things because you apply them in the next stage of this lesson. We'll take examples so that you can really see how we can use some of the things we have mentioned earlier on. Example number 1. Write the formula of calcium hydroxide. Now, how many elements or radicals are there? There are 2. There's calcium and there is hydroxyl ion. So, what is the valency of calcium? +2 or 2. What is the valency of hydroxide? -1 or 1. So how do we do it? You take the one which is the valency of hydroxide and give it to calcium, and take the valency of calcium and give it to hydroxide. Now that's why we have there calcium 1. The bracket there is telling you that the 2 is not only for hydrogen, it's for both oxygen and hydrogen. So if there are more than 1 atom in the radical, you must put in a bracket to show that the 2 is for both of them. So that's why we have calcium, open bracket, close bracket, or hydroxide 2. You can see that that 1 is the same as 1 times calcium. So you can as well remove it and it will be good as that. And it's universally acceptable anywhere in the world in chemistry. Now example number 2, you say write the formula of aluminium chloride. How many ions are there? 2. The cation, aluminium, and the anion, chloride. What is their valency? Aluminium is +3, chloride is -1. Remember, valency and oxidation number, the sign is just the difference. So when you interchange them, you will give the 1 to aluminium and give the 3 to chlorine. So you have aluminium 1, chloride 3. So the formula is aluminium chloride. Once you say aluminium chloride, any chemist will say is AlCl3 as the universal formula. Then the next one is write the formula of ammonium tetraoxosulfate 6. Take note that you cannot in any case tamper with the 4 under hydrogen and the 4 under oxygen. They are standard. You can't tamper with them. But you can play around with your +1 and -2. How do we do it? With interchange. NH4, you give it the 2 of SO4. And of course, the SO4, you give it the 1 of NH4. So it becomes NH4, open bracket, close bracket, because there are 2 atoms. And the 2 there are subscripts. Then SO4, with the 1 will disappear, obviously, because I said if you multiply out with the 1, it still give you the same thing. So my wonderful learners, that's how to go about it. The next one is carbon 4 oxide. Very interesting. And oftentimes you would say, where is the 4 coming from? Carbon 4 oxide, I can't see the 4. Today you will see the 4. The 4 is because carbon has oxidation number of +4 and oxygen has -2. So if you give carbon 2 and give oxygen 4, you have C2O4. But they have a common factor, like I mentioned earlier in the lesson. So 2 can cancel out to make it simpler. So 2 into 2, 1, 2 into 4, 2. And because they are valency, you can temper justice and you can do that manipulation. But if they are statutory, attached to the atom, you can't temper with it. So you end up having carbon 4 oxide as CO2. The next example is very, very interesting also because in the name there is no hydrogen mentioned. But from your previous knowledge of chemistry, you know that an acid is any substance that when dissolved in water contains hydrogen ion as its only positive ion. And that's why we say tetraoxosulfate 6. The acid here has introduced hydrogen to a chemist. And that's why you have hydrogen and tetraoxosulfate 6. And of course, when you interchange the valencies, you have it as H2SO4. Apart from water, I'm sure this is the next formula that is very, very common to my students at home, learners, and viewers. Thank you very much for being with me. But before I round up, I will write the formula of calcium hydride. Now here, hydrogen is taking electronegativity. Because remember, I said hydrogen can be positive and it can be negative. We'll discuss that in our next lesson. But now you find out that hydride is -1. And calcium is +2. So when you interchange, you have it as CaH2, calcium hydride. Thank you very much for paying attention. Thank you for being a wonderful student. I hope you have learned. I'd like to introduce my noble colleague as he's giving you the summary of what we have said and the assignment. Remember, your exam is fast approaching. Study hard and you come out with your flying colors. Have a wonderful day.
Hi, my wonderful student. You are welcome once again. My name is Williams Ishaku. I believe you have enjoyed this presentation, beautifully presented by my noble colleague, Mr. Philip Mamman. Just like the topic, element and their symbol, and also compound. He made mention that an element is any substance that cannot be broken down by any chemical means. He made it categorically that we have up to about 118 elements. And there is nothing in this planet Earth that is not represented by these elements. We have elements in almost everything in the world. Whenever you see the periodic table, it's a table representing everything on planet Earth. Again, this periodic table, this element that we're talking about can be represented with symbols. Just like the commercial student, we also have our own symbols where we use a shorthand way of representing element. He defined the symbols as a shorthand way of representing the element. You will agree with me, according to him, that these symbols, some of these elements derive their symbols from the first letter, like hydrogen, carbon. Hydrogen is C, carbon is C, hydrogen is H. There are others that derive their own symbols from the first two letters. For instance, helium, He, calcium, Ca, whereas there are others that derive their symbols from Latin words. From Latin, either or the person that discovered the element. For instance, we have something like sodium, which is Na, natrium, potassium, K, kalium, just to mention but a few. Again, whenever we want to write the formula of compound, we make use of what we call valencies. He said valencies can be defined as the combining capacity of an element. Again, whenever compounds are formed, we have they usually combine with either non-metals with metals or metals with radicals. What are radicals? He said they are elements. They are a group of atoms that behave like a single unit. We have different radicals. He showed you the other radicals that we have, and he gave you an example on how to write the formula of these compounds. Time will not permit me to go back again. However, let me give you this assignment. I'm going to read out this assignment to you so that you get back to us. The first assignment there is define the following. A, radicals. The B part of it is the valency. And the C part is valence electron. Question number 2, differentiate between valencies and oxidation number. There are two different things. The B part of it, write the Latin names and symbols of the following element. Number 1, we have silver. Number 2, we have gold. Number 3, we have copper. Number 5, we have potassium. Number 4, we have potassium, and number 5, we have mercury. Now, the third question, write the formula of the following compound. The first compound there is ammonium trioxocarbonate 4. The second compound, aluminium tetraoxophosphate 5. And the third one is nitrogen 1 oxide. My student, in case you want to read further, we always refer you to the following chemistry textbook that we know that they are good. The first one there, we have Understanding Chemistry by Gordon O. Ojokuku. The second one, we have the New School Chemistry by Asao Yao Ababio. It's a very good chemistry textbook. The last one, you can also use Stan Chemistry Textbook for SS1 by Science Teachers Association of Nigeria. After the assignment, in case you want to forward your work to us, you can use the following numbers. We prefer you using WhatsApp. The first number there, we have Mr. Philip Mamman, 080-2659-8861. I repeat again, 080-2659-8861. Then you can also use Ibrahim Umar, 070-3620-2842. 070-3620-2642. You can also use this number for Williams Ishaku, 081-606-70920. Thank you, my wonderful student. We hope to see you another time. Stay safe and remain blessed.